everyone. We would like to welcome you to today, our 2021 Transportation Technology Tournament presentation. We are from the University of Memphis, and we're happy to be here today to discuss rural ITS solutions for I-40 at Rockwood Mountain and I-75 at Jellicoe Mountain. Our presenters today are Katie Bowman and Paul Holmes Jr. Katie is a PhD student at the University of Memphis studying civil engineering, and Paul Holmes is a senior in his undergraduate degree studying engineering technology. We are from the University of Memphis, and our team name is The Buzz. Our problem statement is rural ITS solutions for I-40 at Rockwood and I-75 Jellicoe Mountain. These areas experience high crash rates due to weather and grade conditions. These areas also experience rock slides. Our partnered agency is Tennessee Department of Transportation.
TDOT Region 1 is located in East Tennessee, which is situated in the Appalachian Mountains. Here you can see an overhead view of the road at Jellicoe Mountain. The existing conditions at Jellicoe consist of low visibility. It's a segment of I-75 between exit 156 Rarity Mountain Road and exit 160. This is a 4.4 mile area. The speed limit in this corridor is 65 miles per hour. The two-lane highway has a mountain ridge to the right of the northbound lanes. As you can see here, areas near the right shoulder consist of various techniques to restrict rock slides, including barricades and fencing. The Hiwassee River, the mountain ridge, and a local paper mill produces ideal conditions for dense fog. There are cautionary signs for falling rock, 10 dynamic message signs, and 10 interchangeable speed limit signs. Here you can view the difference between the fog and a clear day, foggy conditions and regular conditions. Here's the image of February 14th, 2020. Three big rigs wrecked with each other. The traffic was backed up for miles, and because of the conditions, usually the interstate has to be shut down due to lack of alternate exits. Here you can see more of the damage from the trucks.
To address the adverse weather conditions, a fog detection system will be installed. The area under study is approximately 5 miles long, and these 5 miles will be a fog detection zone. A 5-mile fog warning zone on each approach to the fog detection zone, north and south, will be the fog warning zone. The fog detection system signage will consist of 4 static warning signs with flashing beacons saying low visibility ahead when flashing, 8 changeable speed limit signs that will be installed to remind road users of applicable speed limits, 8 dynamic message signs, and 2 highway advisory speed radio transmitters. TMC remotely operated swing gates will also be installed on each ramp to control access to the interstate. TDOT has a table for advisory and control strategies for various road conditions, which is used in parallel with the fog detection system. The dynamic message signs, changeable speed limit signs, and highway advisory radio will be changed depending on the roadway conditions. Within the fog detection system zone, 15 forward scatter visibility sensors will be installed to determine the atmospheric extinction by the amount of scattering and visibility measured, 20 inductive loop vehicle detectors for vehicle detection, and 30 CCTV cameras will be installed for monitoring. The fog detection system will also use connected vehicles to gather data on road weather conditions. The Buzz originally specified a dedicated short-range communication, DSRC, but after recent discussion with the FHWA and FCC, the Buzz now specifies CV2X. Cellular vehicle to everything allows for both direct and indirect communication, which is useful for collection of data. CV2X has been proven to be more sustainable and offers a long-term path for constant improvements. The estimated cost for the fog detection system for I-75 at Jellicoe Mountain is approximately $2.6 million, and this does not include labor costs, or overhead.
Here you can see the road at Rockwood Mountain. As you can see circled in blue, there's a very sharp curve. The existing conditions includes the stretch that experienced incidents at a high rate. It's a 6.5-mile stretch along a two-lane highway. The focus is a 2-mile curve on the eastbound one-way, as it sits a lower elevation than the westbound one-way. I-40 sits in two tiers at this location. The north side sits in a cutout of the mountain, and the south side sits in a field to level out the mountain. The speed limit in this corridor approaching the curve is 60 miles per hour. The highway has a minimal size left shoulder and a full size right shoulder. There are cautionary signs for the 4% grade and signs for lowering the speed to 45 miles per hour for the half-mile curve. Road and shoulder super elevation causes veering into the shoulder. In addition, the westbound cliff is shifting down the slope. I-40 at Rockwood Mountain has a stretch near the 342nd mile marker that is particularly bad. This section averages 3 rollover truck crashes per year due to the veering of the super elevation. Here's another overhead view. You can see in red the eastbound lanes, and you can see it's separated from the westbound lanes. And here are more images of the 4% grade posted as well. Eastbound lane would have a proposed additional signage that includes sharp curve sign with message boards, a flash alert chevron, solar power, and a solar powered radar feedback sign. All of these would be equipped with additional technology to create varying messages depending on the current conditions. And the chevron would illuminate in heavy fog. The estimated proposal for the signage was $28,000.
For Rockwood Mountain in Roane County, landslides have been a problem since the start of construction of the eastbound lanes of I-40 in 1968. The left-hand picture is the slide that occurred during construction. The middle-hand picture is the reconstruction of the lanes after the slide, and the right-hand picture is how the lanes sit now. An approximate 1,200-foot length of stretch on the eastbound lanes need frequent monitoring due to the downward creep of embankment and foundation materials. In 2020, the stretch of interstate required paving and repairs between mile marker 341 and 347 because of the downward creep. The BUZZ proposes the use of slope vision and evolutionary georeference camera system to monitor the downward creep of the slope. Slope vision uses real-time monitoring through movement and surveying radar, MSR, which ultimately detects the slope instability. Cameras will be placed at critical slope zones, and the images will be digitally transmitted to the Traffic Management Center.
Here is a 24-week comprehensive plan. Week 1 would include the engineers briefing the skilled workers and a review of the traffic control plan. Week 2 would be site visits and measurements. And all the way through to week 24, everything is planned out.
The anticipated benefits for this project are as follows: increasing driver awareness by implementing signage at the curb and on I-40 at Rockwood Mountain in Roane County, and install a fog detection system on I-75 at Jellicoe Mountain in Campbell County. By installing the slope vision cameras at Rockwood Mountain and the CCTV cameras at Jellicoe Mountain, it will allow TDOT to keep track of the roadway conditions more thoroughly and quickly respond to any issues. By using CV2X, TDOT can instantly update drivers of hazardous roadway conditions. Ultimately, all these newly advanced technology implementations will improve driver safety along these two stretches of interstate. And we'd like to open up it for questions.
Okay, great. Thank you. At this time, we will have the judges come on with comments. Judges, if you'd like to start.
Yeah, I'll ask a question here first, if you don't mind. So the cost of the fog detection system was $2.6 million. How many accidents did they have in that location in order to kind of justify that cost?
From what we could see, it was around 3 accidents per year. And so, which is relatively small, but just to improve the quality of sight vision for the fog detection system being installed will dramatically increase driver awareness. So just to improve the quality of driving will help improve overall safety.
In addition, usually the accidents consist of big rigs, which often have several millions of dollars worth of goods on it as well. So I believe that high cost of $2.6 million will be offset by that.
Thank you.
Thank you.
I can go next. So thank you very much. A very interesting approach. I do have one question. You can hear me, right?
Yeah.
Yeah. Okay. Some of the ITS strategies that you adopted are of using variable speed limit, etc. So what do you think it takes to integrate this information in real time into Waze or Google Maps, so that people who are using navigation applications are aware of this information?
So that's what the benefit of using CV2X is. It's where you could have both direct and indirect communication. So implementing the indirect communication, so both sending data to and from the TMC is beneficial.
We originally had the DSRC, which doesn't use indirect as well. And because we have the capability with the other system, you would be able to send and receive information.
Okay, but maybe right now, if we deploy this application in 2022, for example, January. So what do you think TDOT needs to do to make sure that that information is conveyed through Google Maps or Waze or any other navigation application?
Zones definitely need to be implemented into Waze and Google Maps where exactly these locations are. So definitely implementing the fog detection zone into Waze and letting the drivers know that there's changeable speed limits in these areas will definitely be beneficial to the driver.
Google Maps already has a built-in delay system. So once the TMC receives these notifications from this zone, it would be beneficial if they had a partnership. They send the same alert or notification to Google Maps or Waze as well.
Okay, thank you.
Did we have any other questions?
Yep, I have a question. My question is in regard to your use of CV2X technology. As you know, it's an experimental technology. So I'm wondering what aspects of your project rely on CV2X, and what is your plan if that technology doesn't work as you think it will?
So the first step of the plan is to implement the signage. We believe that additional signage for the heavy fog and being able to constantly remind drivers of safety to slow down is the first step. That's the first step of the proposed plan. The second step would be to implement the technology. The technology will be an additional backup to the additional signage. And that way, as the technology continues to emerge, the signs will already be in place, and we'll be able to know whether the signs have begun to be effective or not.
Okay, I guess, how do your signs get data? How does it know whether to display fog? Does that rely on the CV to X, or is that the scatter technology that you showed, or both?
It's the forward scatter visibility sensors that will use to detect the fog, and then the CV2X will be a secondhand usage to help communicate to road users of hazardous road conditions, but also help communicate to a TMC of what road users are seeing as well. So it'd be a secondhand form of communication.
Your signs do not rely on that for data. Okay,
No.
thank you.
Question on loop detectors. So I don't see those too often anymore. Why did you choose loop detectors for the fog system?
Just to understand how many vehicles are going in and out of the detection zone, just to gather data.
And also, usually the main issue with hot fog is reaction time is cut very short. So if you are having your traffic back up in this hot fog, having your signs display like, hey, there's heavy traffic in this area before you get to it will help the drivers to more safely slow down before they get into the fog zone.
Yeah. Why loop detectors versus side fire radar detectors?
We originally proposed loop detectors. We're not opposed to searching into more advanced technology, and we're willing to research and work with TDOT and understanding what is more advanced and working with TDOT and moving forward with technologies as they advance.
A question on that slope vision system.
Along those
Go ahead,
lines.
Val.
Well, if yours is still related to your last question, go ahead.
No, I was going to ask a question about that slope vision technology.
Okay, that's fine. I was going to ask about relationship with TDOT. So go on with the technology, then we'll get to TDOT.
Yeah, I was just curious on that slope vision. Is that a commercially available technology right now?
Yes, I believe so.
Does it use AI to detect the slope creep, or how is it doing that?
It's using MSR, so it's using survey radar.
Okay, go ahead, Valerie.
Yeah, I was going to ask what TDOT's reaction has been to this, and what are the chances of it being implemented?
TDOT is definitely responsive about the fog detection system. They installed a similar system in Calhoun, Tennessee, which is what we modeled ours off of. It's pretty similar. And so that system has worked really effectively. And then for the landslides, they're really stuck at a standstill about spending so much money on repairing the slope that they don't know where to move forward. So this is a way of monitoring the slope and understanding where exactly the movement and the creep is.
Okay, thank you.
Okay, thank you. Did we have any questions from Kathleen or Egan?
I believe Priyanka was asking something, but we couldn't hear
Yeah,
her.
sorry, I was on mute, but I do have one question. I'll wait for the rest of the judges to
Oh,
ask.
Kathleen or Egan, if you have a question, you can let us know. In the meantime, we have Egan.
Yeah, just one quick question. I was interested in the collaboration between you all and the DOT. I think Valerie started to ask the question on whether or not there was some sort of interest, the next steps with this sort of a system. From some of the responses you provided so far in terms of the slope issue, it seems like that's sort of open-ended. Did you get a chance to really think about what would be the next steps on that? If the system was going to actually instruct folks and where the slope is going to, and the progression of the slope, what then?
Well, the main issue with the slope is a lot of times the highway is too close to the embankment or the cliff. And so oftentimes when you have rock slides, drivers won't have enough time to react to it. So we proposed the ITS solution that would help you monitor this in real time. A lot of times, the solutions are fences or barricades or things of that nature, which may or may not hold back the rock. But with the slope detection, you'll have a better knowledge of when the slope is changing and you can monitor it over time. So this will give you an evaluation to start keeping track of maybe patterns that occur. TDOT was very excited about it. They have been searching for alternate ways to do it. We thought of making different things that would hold the rocks back, but we kept it limited to ITS solution.
Okay, thank you. All right. So if Kathleen, if you don't have a question, what we'll do is we will move on to the next team, and we'll prepare for the University of Massachusetts Lowell.
Thank you, everyone.
And at this time,
Thank you.
thank you so much for presenting.